Hello, young people. You made it. Here we are, final video of Unit 2.1. Earth's internal energy. We're talking about all that heat that's stored inside the planet, where it came from, and yeah, this will be a pretty quick one. We've got three main sources for Earth's internal energy. The first is it's just leftovers. It is leftover energy from when the Earth formed, when the Earth first formed 4.6 billion years ago. Imagine 4.6 billion years ago, we've got this brand new sun, and the sun is, it's got a lot of gravity, and there's a lot of stuff in orbit around the sun. And the stuff's flying around in orbit around the sun. And, every so often, these blobs of rock and dust and whatever, they crash into each other. And every time they crash into each other, well, for one thing, when they hit, there's thermal energy. It releases thermal energy. When things are moving, they have what we call kinetic energy. And when those two blobs slam together, they're going to lose kinetic energy. And that kinetic energy will turn into thermal energy. And then those two blobs slam into a third blob. And our main blob keeps getting bigger. Eventually it's going to be the Earth, but right now it's just a bunch of blobs of stuff. But every time a new blob slams onto it, it's more thermal energy. The next thing is, once we get enough blobs, anything that has mass has gravity, including you, including me. Anything with mass has gravity, and the more mass something has, the more gravity it has. So the more blobs we get, the greater the gravity of our big blob. We could get all fancy and call it like proto-Earth or whatever, but I like big blob. It's a big blob of stuff. But as our big blob gets more gravity, it starts pulling itself together. It starts pulling the stuff at the surface toward the center. Well, if you keep everything else equal and you increase pressure, you also increase temperature. And the more gravity there is, the greater the pressure inside the planet. So as it gets bigger, the gravitational pull of that blob on itself starts to squeeze everything in the middle. We're squeezing it, we're squishing it down, we're smashing it together. These blobs all forming together, and it's causing the inside to heat up even more. And then finally, there is radioactive decay happening. If you don't know what radiation is, you just know it's scary, or it's that thing that the dentists use to take pictures of your teeth. And for some reason, they don't ever want to stay in the room when it's being used, right? Well, radiation, all it is there are certain atoms of certain elements that are just unstable. They're unhappy. They want to be something else. They're not happy with the way they were born. And these elements, it's a happy story, because eventually they become who they were meant to be. And these elements are called radioactive elements. And the only way that they can become the element, the atom that they want to be, we're talking individual atoms here. You'll have an atom of uranium. And that atom of uranium wants to be lead. And the only way that it can become lead is for it to undergo radioactive decay. Radioactive decay always releases particles. It's shedding the stuff it doesn't want, it doesn't need. And eventually it sheds enough stuff that it becomes lead, and that's something that's stable, and now it's a happy atom, and it will live out the remainder of all eternity as a happy lead atom. Because radioactive decay releases stuff, those atoms are releasing energy. It's firing stuff away, little tidbits of matter, subatomic particles, with a lot of energy. So, that's our third source of energy inside the Earth, is radioactive decay. All right, young people, thanks for bearing with me. You made it all the way to the end. I hope you took some good notes, and you're getting yourself prepared, because next time in class, we're going to be doing explorations from Unit 2, Lesson 1. See you next time.